This is CPM Precalculus Chapter 3, Number 10. So solve these problems using powers of the same base. So that's the key words, same base. So here we have 9 to the power of x. 9 is the base, so base 9, the exponent is x, equals 3 over 3, again 3 base 3 to the power of x. Okay, when we don't have an exponent here, right, 3 we know is always to the exponent of 1. So what we want to see is using the same base hint, we want to go ahead and make this in the same base as this side here. So we can do that because we know we can go ahead and work on one side and then the other, right? 9 is equal to base 3 squared, right? 3 squared is 9, so we could rewrite the left side like this, okay? So that's still equal to the right side, and we could go ahead and use the properties of the properties of exponents to write the right side as 3 since it's the same base. Since we have 1 in the numerator and x in the denominator, we're just going to subtract from the numerator's exponent, the same base, the exponents, right? It's the numerator minus the denominator's exponents if we have the same base. So we can go ahead and simplify this. That's just 3 to the power of 2x is equal to 3 to the power of 1 minus x. Since now we have the same base on both sides, we can now set, like this now arrow means the exponents are equal to each other. So that means 2x equals 1 minus x, right? Solve for x, we'll add x to both sides. We get 3x equals to 1. Let's continue over here. 3x equals to 1. We'll divide both sides by 3. The 3 cancels out and you're left with x is equal to 1/3. Okay, so that's how you do this. That's how we solved for x. Let's go on to part B. Part B says 25 to the power of x is equal to the 5th root of 5 to the power of x. Again, the same base, well, we have 25 and 5. So we know we can convert 25 to the base 5 by knowing that 5 squared is 25, right? And we can go ahead and rewrite the root as a fractional exponent because the 5th root here is the same thing as the 1/5 power, right? So again, we could rewrite this as just 5 to the power of 2x. And we can rewrite this as 5 to the power of 1/5 x, right? Because we're just multiplying the exponents here and here. Same base, right? 5 and 5. That means 2x, the exponent, is equal to 1/5 x, the exponent here. Okay? So 2x is equal to 1/5 x. So before you go and divide both sides by x, we shouldn't do that because then we're just going to get rid of x and not have any variables. But what you want to do, remember, is combine like terms. So let's go ahead and subtract 1/5 x from both sides. Then we have on the right 0. And on the left we have 2x minus 1/5 x. Let's go ahead and do that really quickly. On the side, we have 2 over 1 minus 1 over 5. The common denominator, again, is going to be 5. So we're going to multiply this by 5 over 5, right? That's the 5 in the denominator. And that's equal to 10 over 5 minus 1 over 5. So that's equal to 9 over 5, right? That's just a quick side math. So we know 2x minus 1/5 x, right, is just going to be 9/5 x. Now we could divide both sides by 9/5, right? They cancel here. We get x equal to 0 divided by 9/5. Well, that's still 0, right? Even if we went and changed that to say, well, that's equal to 0 times the reciprocal of the denominator, it's still 0, all right? So that's how we get x from this equation using powers of the same base, all right? That ends CPM Precalculus Chapter 3, Number 10.